So we're going to be talking about interior and exterior angles of triangles and quadrilaterals. So we're going to find the missing angle measures and then remember to give reasons. I'm just going to state the reasons here on the video as to avoid a 25-minute long video. So for 1a, what is the angle value of x? Well, I know that the sum of the interior angles of a triangle is 180. So I take 45, 63 away from 180. I get 72 as my x value. Over to 1b, I have a quadrilateral. I know that the interior angles of a quadrilateral must equal 360. So I take 87, 96, and 75 away from 360, and I'm getting my value of 102 degrees. 1c, I need to find x and y. Okay, so two variables. You can go about it a couple ways. I decided to go using the exterior angle of a triangle is equal to the sum of the two opposite interior angles. So I have 118 is equal to 39 plus y. Solve for y. I end up getting 79 as my y value. And then we can use the sum of the interior angles of a triangle to determine the angle for x. The other way you could have done it, supplementary angle here, 180 minus 118 gives me my x value. Sum of the interior angles, I would find my y value. I'm just going to stay to the left side of the page. So for 1e, I have a quadrilateral here, and I need to find angle x. Sometimes it's not as easy as just solving for that variable directly. We need to find other pieces of information before. So I've gone ahead and labeled this as angle A, angle B, angle C, and angle D. So I can determine the angle A based on 180 minus 100, gives me an A value of 80. Supplementary angle theorem is 180 minus 95 gives me B, which is 85. 180 minus 130 gives me C, which is 50. Now I can't do it over here because there's no given numbers or no given angle measures, but I know that the four angles inside this quadrilateral equal 360. So I can determine the angle D value by using 360, subtracting the three solved sides, and I am getting 145 degrees. Now I can go ahead and solve for angle X by using the supplementary angle theorem, which would be 180 minus our D value, which is 145, gives us an X value of 35 degrees. 1G, I have this figure here, which looks like there are two triangles. Piece of information, this, and this all indicate that these are equal side lengths. So ACD triangle is an isosceles triangle, and triangle ABC is also an isosceles triangle. So when I have the rule of isosceles triangle, these two side lengths are the same, and I'm given one of the bottom angles, I know that the other one must be the same. So right out of the gate, x is equal to 50 based on recognizing that rule. Now I can go ahead and solve for angle C. Angle C would be 180 minus 50 gives me 130. And then my triangle ABC is also an isosceles triangle. So this is 130, which means that this angle y must be the same over here as well. That's also y. It's the same value. So I take the triangle 180 minus 130, which would be 50, and then divided by 2, because these must be the same. So then I have a y angle of 25 degrees. For question number 2, now we're going to be using some algebra in order to find the value of an unknown and then find the angle measure. So you'll notice that this here for 2a, we have a quadrilateral. All angles inside the quadrilateral equal 360. So 360 is equal to this plus this plus this plus that. So how many x's do I have? 1, 2, 3, 4. 4x. And I also have a negative 30. And then I have a negative 40. Then I go ahead and solve for my x value. I end up getting an x value to be 107.5. So that's what these two are. I still need to determine and indicate what these two angles are. Well, x minus 30 is equal to 77.5, and then x minus 40 is equal to 67.5, because we know the value of x. For 2b, same approach, except now we're dealing with exterior angles of a polygon. We know that the exterior angles of a polygon must add to 360 degrees. So this plus this plus this plus this gives me 360. Or if I want to write it a little bit quicker, how many x's do I have? I have 1, 2, 3. I have 4 x's, and I have a positive 7, positive 4, which gives me positive 11, and then I have a negative 5 and a negative 10, which gives me negative 15. I go ahead and then solve for my value of x, which I get to be 91. So my x value is 91. Now I go ahead and plug in the value of x into each of these, and I get my angle measures. So x minus 5 is 86, x plus 4, 95, x plus 7, 98, x minus 10 is 81, which gives me a total of 360 degrees. So if ever you're doing that and plugging values back in and you're unsure, you can just simply add them all up and see whether or not it equals the angle value that it's supposed to equal. Okay, the distance from the ground to Peter's eye level is 1.7 meters. To measure the height of a tree, Peter stood where the angle to the top of the tree was 45 degrees. At that point, he was 10.2 meters from the tree. How tall was the tree? Okay, so we have a bit of a diagram here. So this is Peter, and his eyes are 1.7 meters above the ground. He was looking at the tree so that the line of sight created a 45-degree angle with the top of the tree. So this is 45. Given the distance, we can assume this is a right angle. So now we can go ahead and we're looking for the height of the tree in its entirety, not just from this point, but this whole thing, right? Because they're standing on the same ground. So if I go ahead and take some of this off here, that'll help so we can see here. I have 1.7 meters, and I have a distance of 10.2 to where Peter was standing. Well, this is 90 degrees. This is 45. That means this has to be 45 as well, because this is automatically an isosceles triangle. Once this is 45 and 45, I can then determine what this side length is here, because these are equal distance, because these angles are the same. So I'm not actually doing any math. I'm just recognizing what the rules are and just simply stating and filling in the blanks. So because this is 45 degrees and 45 degrees, those are the exact same. So these side length and this side length must be the exact same. So then I have from where Peter's eyes are to the top of the tree is 10.2 meters. So 10.2 plus 1.7 gives me a value of 11.9, which means that the tree is 11.9 meters tall. If ever you're wondering why I went from 45 degrees and just put that in there, well, ask yourself, what are the sum of the interior angles of a triangle must equal? Well, they must equal 180. I'm given 45 and this is 90, so the only other explanation that would work mathematically would be 45. The other addition would be the fact that we can assume that this 90 degrees and this 45, we need to take whatever value this is, and it's the exact same because these are the same distance. Yeah. All right, last one. To show that the sum of the measures of the interior angles of any quadrilateral is 360 degrees, join the four vertices to a point inside the quadrilateral. Okay, so I'm just going to quickly draw that. I'm going to use some different colors here. So from one vertice to the middle, let's do another color. From another one to the middle, and let's go here. From this to the middle, and purple. Right, so all these lines, so this, and I'll make this a little bit more obvious here with the thicker black line. So this shape, just excuse my little kind of not awesome drawing. So this shape, I'm going to do it again. Let's try one more time. Hey, better. So the shape that I'm outlining in black is the quadrilateral. And I'm taking the four corners of it, and I'm drawing a line to the middle where they all would meet. How can we use the sum of the measures of the interior angles of the four triangles to show that the sum of the interior angles of the quadrilateral is 360? Well, sum of interior angles equal a circle. So if I was to quickly draw this around, let's go back to blue. If I was to draw this around from this angle to this angle, to this angle, to this angle, to that angle, we have essentially created a circle. And we know that a circle is 360 degrees. So that's how we would use the theorems to prove that this is in fact true.